Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find directional limits at infinite discontinuities. Don't forget to visit our website at math.serve.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, let's take a look at question number 1. We're to find the limit as x approaches 0 from the left of 2 cotangent 2x. Okay, so we can go ahead and factor out this 2 from the limit using the property of limits. Factor out the 2, so we have 2 times the limit as x approaches 0 from the left. Now, using our identities, we know that cotangent theta is cosine theta over sine theta. Okay, let's write that on the side here. We know that cotangent theta is cosine theta divided by sine theta. All right, let's take advantage of that identity to simplify the process. So if we have cotangent 2x, applying this identity, we'll have cosine 2x divided by sine 2x. Okay, now we're going to evaluate this limit by substitution. So we'll have 2. Now we're going to plug in 0 from the left direction along the x-axis into the x's. We'll have cosine 2 times 0 from the left over sine of 2 times 0 from the left. Okay, so this becomes 2 cosine 2 times 0 from the left is simply cosine 0 from the left over sine 0 from the left also. Okay, now we have 2 times, what is cosine 0 from the left? In order to accurately determine this, it's beneficial for us to take a look at the graph of the functions. Let's look at the sine and cosine graphs to determine how the function behaves as you get really close to 0 from the left direction along the x-axis. Okay, so let's look at the cosine function. At 0, it's something like this. And then for the sine function, at 0, it looks something like this. Okay, so for cosine 0 from the left, as you're approaching 0 from the left, what y value are you approaching? You're approaching positive 1. Okay, so cosine of 0 from the left is simply going to be 1. All right, how about sine of 0 from the left? Sine of 0 from the left, as you're getting arbitrarily close to 0 from the left on the x-axis, what y value are you approaching? You're approaching 0. But what is the sign here? You're approaching 0 from the bottom. Okay? So as you approach 0 from the left on the x-axis, you're approaching 0 from the bottom on the y-axis. Remember, the limit is basically the x-coordinate of the points that you're approaching. Okay? So since you're approaching 0 from the negative direction on the y, the value of this limit is going to be 0 from the left. Now, if we simplify this expression, we'll have 2 over 0 from the left. And we know what 0 from the left is. That's the same thing as 2 over negative 1 over infinity. And then we multiply the numerator by the reciprocal of the denominator. You're going to have 2 times negative infinity over 1. And your final answer is negative infinity. All right, let's take a look at question 2. We're going to find the limit as x approaches negative 3 from the right of negative x squared divided by 3x plus 9. We're going to evaluate this limit by direct substitution. So let's go ahead and do that. We'll have negative. If we plug in negative 3 from the right in the numerator, we'll have negative 3 from the right square divided by 3 times negative 3 from the right plus 9. Okay, now let's go ahead and simplify this. We'll have negative 3 from the right square. That's simply going to be 9. And then in the denominator, if you multiply this, we'll have negative 9 from the right plus 9. And then let's simplify further. We'll have negative 9 over negative 9 from the right plus 9 is simply going to be 0 from the right. Okay, and then if you simplify this, we'll have negative 9 over 0 from the right is 1 over infinity. So we'll multiply the numerator by the reciprocal of the denominator, which is infinity over 1. Your final answer is going to be negative infinity. Okay, so don't forget the fact that 0 from the right is the same thing as 1 over infinity. Okay, if you think about a very small positive number, is the same thing as 1 divided by an infinitely large number. Okay, and also 0 from the left is equal to negative 1 over infinity, or 1 over negative infinity. This is a fact that we used in problem 1. Now let's take a look at question number 3. We're to find the limit as x approaches 1 from the right of negative x minus 3 divided by x squared minus 4x plus 3. All right, so let's go ahead and see if we can reduce this rational expression. We're going to factor the denominator using the x game. So AC from the denominator is 3, and B is negative 4. The two numbers that work, negative 1 and negative 3, multiply to yield 3 and add to give you negative 4. So I can write this limit as the limit as x approaches 1 from the right of x minus 3 divided by x minus 1 times x minus 3. Now you notice that the x minus 3's can cancel out, and then the problem now reduces to the limit as x approaches 1 from the right of 1 over x minus 1. Okay, now let's go ahead and substitute. We'll have 1 over 1 from the right minus 1. Okay, if we evaluate that, we'll have 1 over 0 from the right. So remember what 0 from the right is, right? So this is going to become 1 over infinity. If we multiply the numerator by the reciprocal of the denominator, we'll end up with, well, we have a minus here, so let's not forget that. We have negative, 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 so our final answer will be negative infinity. Okay, so there goes your limit. All right, let's take a look at question number 4. We want to find the limit as x approaches pi over 4 from the right of secant 2x. Okay, so before I well, let's go ahead and substitute. So we're going to have secant 2 times pi over 4 from the right. Okay, now let's simplify that. We have secant 2 goes here once, 2 goes here twice, pi over 2 from the right. Now we know the trig identity relating secant and cosine. We know that secant theta is equal to 1 over cosine theta. All right, so what we're going to do is express this as 1 over cosine pi over 2 from the right. Okay, so the question now is, As x gets arbitrarily close to pi over 2 from the right direction, what y value are we approaching and from what direction? To easily answer this question, let's go ahead and draw the sketch of the cosine function and closely examine what happens as x approaches pi over 2. Okay, so sketch the cosine function. You know the maximum is at 1, and then we have pi over 2, and then pi. This is pi over 2 right here. We know the cosine function starts from the maximum and then drops down to the center, and then at pi, it's half a period, goes to the minimum. Now, as x approaches pi over 2 from this direction, what y value are we approaching at this point? At this point, the coordinates of this point, let's go ahead and write it down. The coordinates of this point are pi over 2, comma 0. Okay, so the y coordinate that we're approaching is 0. But from what direction? As x approaches pi over 2 from the right direction, the function approaches 0 from the bottom. Okay, so how do we indicate that? It's going to be 0 from the negative direction. Okay, so what does that tell us? It just simply tells us that 1 over cosine pi over 2 from the right is equal to 1 over 0 from the bottom in the direction of the y. Okay, now what is 0? An infinitely small negative number that can be written as negative 1 over infinity. Alright, so if we multiply the numerator by the reciprocal of the denominator, we'll end up with 1 times negative infinity over 1, and your final answer will be negative infinity. Okay, so there goes the value of your limit. So now you can go ahead and try out some of the practice problems by clicking on this link, and be sure to check your answers. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. And please post a comment in the comment section to let us know what you think about this clip, or if you have suggestions as to other tutorials we can make to assist you. Like as indicated earlier, feel free to visit our website at mathgodserved.com. Thanks again for watching, and have a wonderful day.